Hi everyone, welcome back. This is the part 2 of SQL 50 problems in Leetcode. If you have not seen the part 1, then I would link the video in the comments below, and also it'll be here somewhere in the video itself. You can go and check that out first and then come to solve the part 2 of the problems. So in the part 1, we have solved almost 12 problems out of the SQL 50, and then we will start from the 13th problem today. So let's dive in. Before I jump in, one thing I would like to highlight here is that the one key lesson that we took from the part 1 is that always break down your problems to understand what are the steps to follow rather than kind of jumbling your steps here and there, because that won't give you the necessary output or the result that the problem is looking for. So that's definitely something that we are going to follow today for this video. Okay, so the first question is managers with at least 5 direct reports. Okay. Managers with at least 5 direct reports. So the table has employee ID, name, department, and manager ID. Okay, that's all. That's only the 4 columns that we have. Write a solution to find the managers with at least 5 direct reports. Okay, yeah, I remember. Actually, I have got this question multiple times in multiple interviews. I haven't solved SQL 50 earlier, so I did it based on my knowledge itself. But now that I see the question here, I understand that this is indeed a famous question because it's there in Leetcode SQL 50, right? Okay, so let's do that. Okay, so at least 5 direct reports. First, let's break down the problems into different parts. What do I have? I have only one table, and I would need to find out the ID and manager ID. So basically 102 ID has the manager as 101. That's what it is. And their direct reportees would be 101 having reportees of 1, 2, 3, 4, 5 or not. So 101 essentially is the manager who has 5 direct reportees. How am I getting that? That's basically I have to do a self join here. I have to join based on manager ID and try to find out what is the number of count of distinct IDs under each manager ID. That is the problem. That's it. Let's do that. So I would first write a CTE, and what I'll do, I'll join the tables, like the same table twice, basically self join. Select, I would use manager ID. Do I need the names? Yeah, I need the name. Okay. So basically what we are doing, we're joining the first table manager ID with the second table ID. So manager ID is the primary key here. That's what we are taking. And we are taking, let's say, manager ID from E1, and we are taking name and ID basically from E2, right? That makes sense? Okay, so basically I'm taking the first table, I'm taking the manager ID from there, I'm taking the name of the manager, this as manager name. Let's write it like this, manager name, and then ID is basically we are taking count of E1 ID, right? That's count IDs. Join this employee.managerID.id. That's the manager name that I'm taking. I'm counting IDs under manager. That makes sense. And then do a having. We'll do a group by first. E1.managerID and E2.name. Basically, that'll be 1-to-1 mapping and having count of E1 ID greater than 5, or at least 5. So greater than equals to 5. I don't think I need CT here. First I thought I'll need, but I don't think I'll need CT here. Let's run this and check. Okay. Near count. Okay, sorry. There should be a comma. Invalid column name, manager ID. Oh, I'm sorry. There should be just manager ID. Anything else? E1, E2, manager ID, E2.id. E1 manager ID, E2.name. Okay. Should work. Okay. It's just I need 101 John 5. So I don't need all of that. I'll just need E2.name and that's fine. Count is also something that I don't need. And I would just need group by E2.name. Should be fine now. Let's check. Do I need to order it by something? Return the results in any order. So I would need only name, not manager name. Okay, let's submit. Okay, so I don't need John and John. Okay, since I've grouped it by John, that's why it's coming like that. Okay, I can do group by employee ID, right? E1 manager ID. And E2 name. Let's submit that way because two of the same name can have two different IDs. Yes, so this is accepted and hope you understood the areas. Let's go on to the next. Okay, so this is the second question, confirmation rate. Signups, there's a table called signups. There is user ID and timestamp. User ID of the column is the unique values for this table and each row contains information about the sign up time. That makes sense. And there's another table, confirmations, user ID, timestamp and action. So another table where we get user ID and their timestamp, also the action in an enum or enumerator category, either be it confirmed or timeout. So we need to find out the confirmation rate of a user is the number of confirmed messages divided by the total number of requested confirmation messages. This confirmation rate of a user that did not request any confirmation message is 0. Okay, round the confirmation rate to 2 decimal places. Let's look at the input and output table. I think that will be more clear. The user IDs, we have signups table. There are 4 separate user ID that I can see and there's timestamp of sign up. And then confirmation table where there is user ID, timestamp and if they're timed out or confirmed in terms of sign up or not. So output that they're looking for is user ID 6, confirmation rate is 0. What they're looking for is that for user ID 6, the confirmation rate is 0. That is 0, that means the user ID 6 has timestamp at this, like he started it sometime around 10:39, but there is no information available for user ID and their action on the confirmations table at all. So that's confirmation rate equals to 0. For 3, both the time it is timeout. So that means 0, 0 on top of one time sign up trial, or once the user ID 3 tried to sign up but it was not a confirmed action, so that's why their confirmation rate is 0. And then let's say for user ID 2, so they tried to sign up once and one was confirmed, one was timed out, so that'll be 50, yes, 50% chance. And then 7 would be 2 out of 2 or 3 out of 3 times it was confirmed. So great, that's what we are looking for. And then let's go and think about the problem, break it down into steps. So first, what we have to do, we kind of have to use this one as a left table. It's understandable, 3726, because we need all the users. We don't necessarily need the timestamp, so we don't have to worry about that. Then we have the user IDs. That means 3 will be mapped with 3 both the times, and 7 will be mapped with 7 thrice, and so on and so forth. That way we will be counting the actions. How many times there was a timeout. Timeout can be considered as 0. We can use a case when statement here, and then confirmed can be 1. And then we can take out the percentage confirmation ratio based on this case when statement. So hope that is clear. Now let me break down or do the SQL code for you. So I think that will be much easier. So first, let us do the join. Okay. So select user ID. I think there will be a.user ID. Mhm. That makes sense. With CTE, we have the a.user ID, b.user ID from both the tables, joining, so there will be a left join. And then what we are doing, we are basically taking the timeout column. Whenever there's a timeout is, whenever the action is timeout, then it's 0. Or let's do otherwise. Okay, let's do, if it's confirmed, then it's 1. Because what will happen for anything for user ID 6 or any such user IDs which do not have any information on the confirmations table, their actions will be null. And if the actions are null, then that means we would need this one is fine. We would just need basically the confirms to be 1 and everything else to be 0. That will do. Let's do that. Okay, so let's try to run this query. What I'll do, I'll just show you first what's this query do and what does this query do, and then after that we will just try to do the next part of the try to solve the next part of the query, right? Okay, so let's see. Confirmed, right? First confirmed. Yep. Left joined confirmations. Okay, sorry, my bad. So this will be sign ups and confirmations, and then A user ID and B user ID. Yeah, should work. Let's see. At least it should give us the desired results that we are looking for. So wrong answer, that's understandable. So we have user ID and flag, and then we have all the separate flags, right? So what we will do, we have to now from here have to find out, let's say, what's the count of flags that we are getting on top of what's the sum of flag that we got, right? That makes sense. So count of flag for 3 would be 2 and sum of flag would be 0. So 0 upon 2 would be 0%. Same for 7, it will be 3 upon 3, that's 1%, and that's what we need, right? And then for 2, it will be 1 by 2, that's 0.5, and 6, it will be again 0 by 1. So that's 50%. That makes sense. So let's just do it. One sec. So we have to take the user ID and then we have to take the sum of flag by count of flag, right? So count of sum of flag by count of flag, and then you have to take, since this is int, so we have to take it at float level. So I can just do 1 into 1.00 to get the confirmation rate. Since we are not asked to convert it into percentage, we are not doing that. And just do, let's say, from CTE group by user ID. And what's the column name? Column name is fine. So this ideally should give us the desired result altogether. And one other thing, since it needs to be rounded up to 2 decimal points, let's just do that right now and run it. Yeah, so this is accepted. Now let's submit. Accepted. Okay, so let's move on to the next question. So again, what I'll tell you multiple times repeatedly is whenever interviewer is asking you one particular question, write it down in your copy, because that's the easiest way to do a dry run and to map the results in your mind before just directly answering it. Because most of the times what I have seen, even in, let's say, product companies, they won't give you a pad to solve your question and then where you can submit and see the result, but rather you'll just have to write the answer in a notepad. You won't be able to solve and see the result for yourself. So always try to do any problem, or basically try to learn any language by writing it down in your copy. That's the easiest and fastest way, and like the most basic way to learn everything, to make your base stronger. So hope that's understandable. Let's move on to the next question. Not boring movies. Okay. There's ID, movie, description, and rating. ID is the primary key. There's movie name apparently, and then description and the rating. Write a solution to report the movies with an odd numbered ID and a description that is not boring. Okay, so let's see. ID would be which are odd numbered, so 1, 3, 5, and after that we'll have to give the rating which is not boring. Return the results. Boring as in how are we defining boring? Okay, the description is not boring. Got it. So basically we have to pick out the IDs which are odd numbered, 1 and 5, and then which the description does not contain boring, and that's it. We just need output ID, movie, description, rating, and the order result by rating in descending order. Okay, I think this is simple enough. Shouldn't, since this is just filtering, and just to break it down to you, what we will do, we will first find out the IDs which are odd numbered. That's one, and then we will figure out the description which is not boring, and then after that we'll just order it by descending order of rating, right? Okay, so let's do that. We need everything, right? Select star basically. So we need select star from cinema, where ID by 2 equals to 1, right? So that means these are even. So the remainder would be 1 if I divide the ID by 2. That makes sense. And the name or the description should not contain, is not let's say boring. They should do. And order by, sorry, we don't need and, order by rating DSC. So let's try this and see. Yeah, okay. Let's see. This gets accepted. Yes, this is. So, okay, this was an easy one. Let's move to the next one. Average selling price. So there's product ID, start, end, and price date. Okay. So units sold, there's another table, product ID, purchase date, and units. Okay. So write a solution to find the average selling price for each product. Average price should be rounded to 2 decimal places. If a product does not have any sold units, its average price is assumed to be 0. Okay. Let's look at the input data. So we have product IDs. So there are 2 product IDs, the start date and end date and price. Okay. Oh, okay, I got it. So basically from start date like 17th February till 28th February, the price was 5. And then from 1st March to 22nd March, the price was 20. Yeah, now that I remember and go through the input table, I remember I was asked this question in some previous interviews earlier. Okay, so that makes sense. All of these questions were coming from Leetcode itself. Okay, now I understand why SQL 50 is so famous. And this is a very practical problem too, just to kind of give you a hint about the real world problems. This is definitely a very realistic problem, specifically in retail clients, or if you're working for a retail company, then this kind of problems is very, very famous. Not even retail. Let's say if you're working in software as a service or some product companies, there also, if you're selling some kind of a product and you want to measure the sales that happened, let's say in between the price of the product changed, then this is how you will do it. Right? Okay. So basically we have units sold here, purchase date is here, and units is here. So we have to get the output as product ID, and their average price was this. Average price, we are getting this by total price of the product by number of products sold. So total, I won't say total price of the product. This will be total sales of the product, right? Sales volume. Sales volume of the product was 500. plus 15 into 20. Yes. And the number of products sold. So number of products sold was 115, right? 115. That makes sense. So what we'll have to do again, just to break it down, you have to find out the purchase date. If the purchase date lies between start date and end date, then the units, sorry, then the price would be this one. And let's say if this particular purchase date lies between the second start date and second end date, then the price will be this one. So that makes sense. And then we have to divide it by total units. So first we have to combine the tables. All right, so let's combine the two tables. First, let's take prices table as the main table. Like we can take this as the left table. So let's select, I would need product ID, comma, price. Then I would be needing units. Price, then I'd be needing units from the unit sold table. So basically prices be the left table, and then we can do units sold based on product ID. Right? So this will be the base table and product ID, and another condition would be the purchase date. V dot purchase date between start date and end date. Right? Once that is the case, that's when we will map the units with it. And we can also get the price, sales value, as price units as sales. So later parts, what we can do select. So since we need product ID, comma, we need sum of sales, count of units. Let's do 1.0. Do we need to round it to 2? I think we do. Yeah, we do. It's a general practice. So anytime you're doing a division, basically we usually make it to float, and then we take 2 decimal points after rounding it. As average price from CTA. By product ID. Let's try and run it and check. Runtime error. Okay, let's check. Round function requires 2 to 3 arguments. Sorry, my bad. This is extra. Ambiguous column product ID. A dot product ID. Yep. Okay, there's a wrong answer. Let me check. Average price. Okay, average price would be sum of sales. Price cross units is sales. That's fine. But this should be fine according to my understanding. Let me just debug and run the first part of the query, and let's check what's happening. If this is taking everything, or if this is mapping everything properly or not. Yes, so 1, 5, 120, 115, 500 and 300. So usually what I want, 800 by 115, right? That's what we need. Oh, I think I've taken count of units. Yep, sorry. Should be sum of units. Nothing such as count of units. Units is an integer, so we do not need count of the same. If it was a categorical ID or some categorical for column, then we would have taken count. But right now we need sums only. Yeah. Let's try and submit and see. Hmm. Prices is this, product is this, but in terms of product ID, average price should be 0. Okay. If it's null, then 0. Let's do that. This function, comma 0. Let's do that. Yep. Cool. All right. It's accepted. Let's move on to the next question. Project employees. So there's a project table, project ID and employee ID, and there's an employee table, employee ID name and experience in years. Write in SQL query. 1 second. Be hydrated, guys. All right, coming back. So write an SQL query that reports the average experience years of all the employees for each project rounded to 2 digits. Okay, let's see. Project ID is 1, employee ID 1, 2, 3, and then experience years is something. We need average experience per project, 2 and 2.5. Got it. So sum of all the experience who are working in project ID 1 versus who are working in project ID 2. Okay, so first our main table is employee ID. So employee ID is there, and then we have the project IDs as well. What we can do, or since we will basically need the average experience by project ID, I think the best way to map it is take the project ID as the main table and then map the experience year to it alongside the employee IDs. So let's do that, and then we can just directly take okay, let's just try to write the query first, and then we'll decide if we'll need CT or not. Right now, I don't think we'll need one. So let's take project ID, comma, we would need experience year, average of experience years as average. Excuse me. Okay, so project ID average experience years as average years from project P left join employee E on P dot project ID. Sorry, P dot employee ID. Group by P dot project ID. And this will be the P dot project ID as well. That's it. We just need a round of this to 2. Average experience here would directly just take up the uh, experiences of the employees alongside of project ID and then just give you the desired number. Sorry, this is employee ID. Sorry. Let's see what have we got. 2 and 2.5. Oh, I have to do a float. Let's try and check. experience years for 2. Project ID 2. So project ID 2 does have 1 and 4. So that's 3 and 2. So 5 by 2, 2.5. Makes sense. Experience year. Cast. Let me use this as float. If this doesn't work, then I have to go by that, like taking sum and then count and do the do the average calculation separately. Yeah, I think it's not taking that way, so let's do that. So instead what I'll do, I'll basically take the sum of experience years by count of employee ID, and employee ID would be p.employee, projects.employee ID, and there can do this, right? Yeah. Yep. Let's submit this and check. The average function didn't work for some reason, so you have to do sum and count. Yep. This is accepted. Let's move on to the next question. Okay, so next question is percentage of users attended a contest. Okay, so we have total user table, user ID and username, and then contest ID and user ID there. Okay, makes sense. So how many users out of total users actually attended a particular contest? That makes sense. I think we need to have the overall user ID and then need to take how many users were there out of that percentage wise, right? Okay, should be good. I think first of all, what I'll do, I'll calculate contest level. Yeah, I'll calculate contest level user count and then I'll just add the overall user count to that and take a percentage out of it. So let's try this. I'll use CTE. This will be distinct, right? Distinct user ID. Contest user ID from register group by contest ID. Okay, so that's done. Then the next one would be I would take the total distinct user count from the user ID table. So select count. I think everything is distinct already. So count user ID as user ID from users. Then finally, what I'll do, I'll join these two together. Like I'll do a cross join basically. There's no direct connection. I'll do a cross join. So select contest ID by contest user ID on top of user ID. I think both needs to be in float, and then if we can multiply by 100 should be the case. Let's see. Sorry. From CT1 cross join CT2, right? So group by contest ID. Let's check this. So right now we had contest ID level data, and on top of that we had contest user ID and user ID. By that It should be at contest ID level. Anyway, I don't think I need to group it by syntax near 1. Okay. Oh, okay, sorry. I don't think I need to do a group by here because we're not aggregating anything, so no need of grouping by. So let's just run this. Invalid object name CT1. Oh, it's only CTE. Sorry. Wrong answer. Oh, I have to round it, but otherwise it should be fine. This and this, and you need to order by, in case a tie, order it by contest ID. So by percentage in descending and then order it by contest ID in ascending. Okay, cool, got it. First I have to round it. Order by percentage. So this column name should be percentage, right? Yep. Order by percentage DESC, comma contest ID ASC. Okay, so we have to order it by 2 columns here, and that's what we have done, and named the column, rounded the column, should be fine now. Yeah. So this is like making the query output aesthetically pleasing and understandable to readers. Let's see if this gives a runtime error. No, this is, yeah, time limit exceeded for these many. So, okay, since I have used 2 CTEs, that's why it is giving me a runtime error or time limit exceeded. Basically 11 out of 14 test cases passed. So it's a huge chunk of user IDs, and the same I think we'll have for registers as well. Yeah, this is a very big one. That's why we're facing time limit exceeded. Okay, so I think I got it. So basically these are columnar format tables. If you try to do cross join usually takes a lot of time in case there's like millions or billions of rows, right? And for the same case, let's say if you do left join or similar joins altogether, then it's taking much more time, and at the end in runtime you're getting a TLE or a time limit exceeded error, right? So instead of doing that, there's a new technique that you can apply, is that even if there are 2 tables, not necessary you have to join both of those. So, and also it's not necessary that you have to kind of refer each of them using where in a subquery or CTE. You can use both of those separately and kind of combine in one formula. Let me just show you. So this is a new technique that I learned. So basically I would need user ID and contest. Okay, so let's take contest ID, comma, b dot user ID, or count of user ID basically. b dot count, b dot user ID by now you can take select, so that's where you can actually take count of user ID from a different table altogether, users as your base, right? So this basically is working as the percentage of the total users that has participated in that particular contest, right? So we can do that as percentage from register B. Sorry. So you get till register. So you have from register B, and that's it. So just to avoid any confusion, and let's run this. we have to take group by contest ID, register B, and we can take, let's say, 1.00 into 100. Let's try and run this. Okay, I have to round it. True. So round this to 2 decimal points. So we'll order it by something, right? Yeah. So we have to order by percentage DESC and then contest ID ASC. So we can use percentage directly because in terms of order of execution, select is executed before order by. So percentage name that we have given as alias, you can use it directly. Let's submit. So this step definitely takes lesser time and lesser space in terms of, sorry. So this definitely takes lesser time and lesser space compared to any kind of join. Definitely lesser than cross join. Cross join is never advised, but let's say for these kind of formats where you need the overall number and there's no way for you to map, you would have had to evidently use cross join, but for a bigger table or a huge table, big data, basically, you won't be needing, or you don't need to use cross join. You can just use both of the tables separately within the same query and it'll run perfectly. So yep, hope you learned something. Let's move on to the next question. So queries quality and percentage. Query name, result, position, and rating. So this table may have duplicate rows, contains information collected from some queries on a database. Position column has a value of 1 to 500. Query with rating less than 3 is a poor query. Okay. The average of the ratio quality. Okay. So there are, this particular table contains query name. So this particular table contains query name, the result, position, and rating. What is the result? The average ratio between the query rating and its position. Okay, let us just move directly to the input and the output. I think we'll get a better idea. So query name is this, and then we have result as these. Okay, the position is 1, 2, 200, and rating is this. Okay. Output is needed as query name this. Quality is 2.5. For cat, okay, at a group level, we need quality is 2.5, which is calculated as average of the ratio between query rating and its position. Query rating and its position. So doc query quality is 5 by 1 plus 5 by 2 plus 1 by 200. Okay, that's quality, average of quality. Okay, and then 2.50 and then 33.33. Poor query percentages, this into quality is this. Poor query percentage. Okay, poor query percentage is percentage of all queries with rating less than 3. So that's 1 by 3. 33.33. Got it. Okay. So basically, since we have only one table, we will need the possession. This is a calculations game. We will need query name for sure. And then what we will need here is that we'll have to calculate the quality. Quality is possession by rating. Sorry, rating by possession, and then summation of that. Okay, so let's do a sum first. sum of position, rating by position. So I have to do a float of this. This should do fine. This is just to be on the safer side, the extra parenthesis. Then sum of this and will need count of result. No, we would need basically count of position or count distinct. Count of result is fine, right? Result as. So why did we take count of result? Because see, both 3 of the times it's returning different results. So that's why I'm taking count of result as just, I think, what's the name? This is position. This is the quality, right? And then the next one would be poor query percentage. So case, we will have to do a case when here, because case when we'll have to do count. Case when rating is less than 3, then 1, else 0, and poor query. So sum of this, no, I would need a sum, right? So sum of this on top of, so sum of rating into this, so sum of case when rating is less than 3, then 1, else 0, end. That's fine. And then we'll need every query, every rating, basically. Then count of rating, both at the level of query name. Sorry. Count rating. This is again needed at percentage level. So we have to multiply it by 100 as poor query percentage. From queries table, group by query name, and then we'll need the result can be written in any order. Select query name, sum of, we would need sum of, so at query level. So let's just debug this right now before running it. So at query level, query name level, basically, so we have dog and then we are taking the ratings divided by position. Sorry, ratings divided by position. And we have taken a decimal count of that. Let's do a round of 2 for this as well. Let's do a round of 2. So I can just do this one then. But count of rating, sum of case when, count of rating into, yeah, I think this can go easily inside this. And this is not needed. Okay, so that's it. As poor query percentage, query name. So basically, yeah, what's happening? We were here rating by position at query level or row level. After that, we are doing a sum and then by count of result. Yeah, we are doing a positioning of these and then summing. So first we are dividing and then we are summing each of these and then we are dividing by the count, and that's what we have done here. Same, if there's a case when rating is less than 3, then 1, else 0. We are doing a sum of that multiplied by 1.00 or 00 for making it making it into two decimal places and then divided by count of rating. Total count of rating at query level and query name level. And then after that, we are just taking the ones who has rating less than 3. Okay, so logically this makes sense to me. Let's run it. This is accepted. Let's submit and check. Okay, this is accepted. So let's move on to the next one. Monthly transactions. So ID, country, state, amount, and transaction date. So ID is the primary key of this table. The table has information about incoming transactions. The state column is an enum type. So primary key is ID. Table has information about incoming transactions. And the state column is an enum type, approved or declined. Let's look at the input first. This is ID, then country, approved, amount, transaction date. Okay, so country level transaction table apparently, and write an SQL query to find for each month and country the number of transactions and their total amount and the number of approved transactions and their total amount. So would be month 1000. What? Oh, okay. I think, yeah, okay. So month is this, then we have country, we have transaction count, we have approved count, we have transaction total amount and approved total amount. Makes sense? Let's do that. And then we have just one. So definitely since we have to take approved amount, so we have to use the case when statement here to filter out only the approved transactions. So let's select, we need month from it, right? So we need country. Oh, then we need month, basically. We need month. So date part function is something that I'll use. We'll use month of transaction date, right? Not only month, we actually need the month and year. So let's do that. Okay. Okay, I think I got it. I have to do a concat. Because of the way it is written, I can do a concat of date part year, comma month, right? And that becomes my whole as month. And then we have the country, and then we have the total transaction amount, right? Number of transactions. So that will be ID. Count of ID is as number of transactions. Transactions count. And then we have the total amount. Okay, sum of amount, right, as total amount. Approved count, transaction total amount, and approved total amount. Okay, so transaction total amount. But before that, apparently we need the approved count. So count of case when, or we can do sum of case when. State equals to approved, then 1, else 0, and as yep, sum of case when state equals to approved, and then 1, else 0, and as approved count, right? And then we can do the same for sum amount as transaction total amount, yes, and then just do the same. So case when state is approved, then we take the amount as 0 and as approved total amount. Approved total amount. From transactions group by country. and month and country basically. Oh, we cannot take the name directly. We'll have to use this. So I used concat function here. Concat function basically just concats two strings together or adds two strings together, so one after each other. So first I took year and then I gave an hyphen as it is mentioned in the output table, and then I've taken the month and then transaction date basically. So whatever is the date part function, and then I've grouped it by country and that particular month column. So this should run. Is there any order? No. Let's try and check. Wrong answer. Okay, let's see. There's an answer. So we need 2018-12 US 2 1. So we need US USDE 12 US 2111 3000 2000. So okay, everything is fine. I think just the order is different. So first I need to order it by, since here it's written you can return the result in any order. So that's why I did that. But apparently that's not the case. Let's just check the column position, transaction count, approved count, transaction total amount, approved total amount, all are fine. I think just I need to order it. Order by ID, is it? Because US ID and month, is it? No, ID is not the case. I need to order it by what then? US, sorry, not US, country, DESC. That's what we're doing because it starts from U, starting from U from the back and then it's coming to D. Let's see if that's the case. No, this is also wrong. For what reason? Oh, because I've taken 0, 1. Okay. No. Okay. So output, I have given 1, whereas the expected output is 0, 1. Okay, so you need a leading 0 in the date part. Okay, so basically to take leading zeros, we have to use convert function. So what convert does is that convert function takes your input and then it converts into the desired data type or desired length. In our case, we need desired length, and for a dynamic length, we would need n varchar as the data type, because n varchar is a varchar, a variable character. It takes variable length of that particular input, right? Okay, so convert function is used here. I can do that, and then let's say we can take the rightmost two characters of that whole string, because that's what we need, right? So we do not need 012 or 011 in case of month of November or December. Rather, we would need any time when it is less than 2, the length of the month. That's when we will add a leading 0. Otherwise, we won't add. So that's the concept here. So I think that's working fine. Date part. Let's try and run it. Needs to be a month. So if you are doing something platform specific, it takes a lot of, aesthetical changes to make sure your output is directly matching with the output that the platform is expecting. So I think that's why majority of the people who are solving these challenges, they're doing it in their own platform, either SQL Server or MySQL or even PostgreSQL. So yeah, these takes a hell lot of time just to make it aesthetically pleasing and matching with the platform's output. Month. Yeah, so this is fine. All right. Cool. Okay, this is approved. 98%. Nice. Okay, now let's move on to the next question. Immediate food delivery, delivery ID, customer ID, order date, and customer preferred delivery date. Okay. If the customer's preferred delivery date is the same, then the order is called immediate. Otherwise, it's called scheduled. First order of a customer is the order with the earliest order date that the customer made. It's guaranteed that a customer had precisely one first order. Write a solution to find the percentage of immediate orders in the first orders of all customers, rounded to 2 decimal places. Okay. So delivery table. Solution, find the percentage of immediate orders in the first orders of all customers. Okay. So customer number 1, sorry, customer ID 1, they ordered twice. This is the first order date, second order date, and nothing is immediate. Okay, and you need overall. Okay, you tell me then. Order has this, it is scheduled. It was the first order with delivery 2 and it is immediate. It is scheduled and immediate. So overall, I need 2 out of 4. That's 0.5, 50%. Okay, got it. So at customer ID level, we have to figure out, is it customer ID level? Yeah, customer ID level first order, if it is scheduled or immediate, and out of that, we have to take the percentage. I think, yeah, okay. I understand the question. Let's do it then. So we have to select the first order first, and then we only have to check the first order. So select, so we have to do a CTE here because ranking usually happens within a CTE. So select customer ID, comma, rank of order date. So we have to take everything. Yeah, preferably everything. Select star, comma, rank of, just rank is fine, I think. Yeah, rank over partition by customer ID, order by order date ASC as rank from delivery. So this will just add another column of ranking, and then you will only select the rows which has a rank of 1. So we just want to see in the first orders how many are immediate, right? So, oh, also another column let's create here is that order date case when order date equals to customer preferred delivery date, then 1, else 0. No, not like that. Let's then, this is immediate, else scheduled, right? And as delivery flag. So we have added 2 columns and then we are selecting the percentage basically. So percentage of count case when. So sorry, before coming to case when, first try from an order of execution perspective. First we have to select the table and then we have to filter for wherever rank equals to 1. So we have got only the rows where rank equals to 1, and then there we will count how many are immediate and how many are not immediate. So whenever it's immediate, then we can take a sum of that, sum of case when, let's say delivery flag equals to 1, then 1, else 0, and on top of we need total count of star. We can do that. Right? Count star is basically all number of rows, all the rows, and out of that, how many were actually 1, and we can take a sum of that. So that's there. We can change it to float, and then we can multiply it by 100 and round it to 2. Sorry. Round the data. Is this extra? Count star. Yeah, this should, no, yeah, this should be fine, right? Okay, so do I need to order it by something? No, it's just the number, right? Immediate percentage as immediate percentage. Okay, let's try to run it and check. Incorrect syntax near 100. Oh, yes. Conversion failed when converting varchar to scheduled date type int. Oh, sorry. If delivery flag equals to immediate, then 1, else 0. Yeah. Okay, let's submit and check. Yep, this is accepted. Not beating a lot of the submissions, but it's accepted nonetheless. Let's see. I think, yeah, this is fine. Let's move on. So gameplay analysis 4. So player ID, device ID, event date, and games played. So we have to write a solution to report the fraction of players that logged in again on the day after the day they first logged in. Okay, so there is a consecutive login. So player ID, the device ID that they are playing from, the event date, and the games played. Rounded to 2 decimal places. In other words, you need to count the number of players that logged in for at least 2 consecutive days starting from their first login date. Okay, so basically we have to figure out only the fraction of people who logged in consecutively after they logged in the first time, right? So okay, so we have to get the first time then. So how can we get that? I think we have to take the we can use the rank function to get the first date that they have logged in, and then we can take the immediate next day and then try to get how many people actually logged in out of the total people that is available, right? So let's take that approach. Select player ID. I don't think I need device ID, so I'm not taking that. Event date. I'm not sure if I need event date. I don't think I do. So I will definitely need rank. So order by event date as rank. Then I would need the lead function, as I said. So I'm creating another column. So it's a little space. There will be a little of space overhead. Right now, this is the solution that's coming to my mind. So you can solve this in multiple different ways or formats. As you know, each SQL problem can be, or any problem for that matter, can be solved in various different formats. I'm showing you this particular way. You can take, let's say, another way of creating, taking only the minimum date per player and then selecting only those dates and checking how many people consecutively logged in from that minimum date. So that's another way. But right now what I'm doing is I'm using a lead function over the event date, immediately the next lead function over, again partition by player ID, order by event date as, let's say, lead date, right? From, this is activity activity. That's it. This is our CT. Now what I need from here, I would need only the rank, which is 1, and oh no, okay. So since I'd have to get the percentage here, so I would need a division, and division would be of every player, not only the uh, not only the player who had let's say um, lead date lead date difference with event date to be 1. So I will take a case when function here. So I will take case when rank equals to 1 and let's say lead date minus event date. So I would need event date also here. Lead date would be, oh, or I can directly actually, I can take the difference here. So let's take date diff day, comma. So my lead date is the one that will be the bigger number. So event date will go first. So this is my lead date flag, let's say. So if my lead date flag is 1, then I will count that particular player. Then 1 else 0, and on top of we will get the count distinct player ID, right? So we need the fraction on top of every player ID that exists. So we will get only the player who has logged in the first date, and then immediately next day also they have a login stamp. So that's the one that we are taking. And then, yep, that's it. I think that's all I need. I would need a round function here. So I'll create this. I'll give a floating operator, and that's set as fraction, right? I think this should do. Let's try to run it. Lead date flag from activity. Accepted. Okay, great. Submit. Okay, not that great solution, but okay, better than the last one, I believe. I think in the last one, I created one extra space column for like separate categories like immediate and scheduled that could have been managed under one 1 or 0 and taken the sum then and there itself. So anyway, as I mentioned, one problem can be solved in multiple different ways, but our goal should always be to solve it as efficiently as possible so that we can reduce the time and space complexity or time and space overhead as much as possible. Okay, so that's it for today. I believe we are concluding the episode here. So till now we have solved, I think, around 22 problem. Okay, not bad. So 22 problems till now, still another 28 to go, and we will solve them in the upcoming episodes. So that's it. Thank you. Take care, and we'll meet you in the next one.